Hello everyone, welcome to our next lesson. Today we're going to be looking at kinematics, looking at displacement, velocity, acceleration, speed, etc. I won't do the topic just. This is just a short preview, or maybe a little bit of a review. But let's see what this is all about. So, if you have a function that gives you the displacement, so displacement is like distance, but with direction. If you found the derivative of that, you would be getting the velocity. And if you found the derivative of that, you would have the acceleration. Now, acceleration can be negative or positive. For instance, if you throw a ball in the air, it is decelerating. There's a negative acceleration. Velocity is different than speed. Speed is always positive. It doesn't matter which way you're going. If you're moving, you have a positive speed. But velocity is positive one way, but negative the other way. Right? A couple other things. If the sign of the velocity and the acceleration are the same, then that means that the speed of p is increasing. And if the sign of velocity and acceleration are opposite, then the speed is decreasing. So let's just look at an example quickly and see how we make out. So first of all, find the expression for the particle's velocity and its acceleration. So finding the velocity and the acceleration for this question, what you need to do is find the derivative of this function s of t, which is your displacement. So v of t is equal to 3t squared minus 3. And the acceleration, the formula is 6t. Now it says draw a sign diagram as well. So a sign diagram would be for velocity. Well, let's factor out the 3. So we got t squared minus 1, which is equal to 3 times t minus 1, t plus 1. And for this one, nothing interesting there. So if I did a sign diagram for this, we would be at t equals 1, and t is at negative 1. So 1 and negative 1. And then we would check to see where it's positive and where it's negative. So at negative a billion, I think this would be positive. At 0 it would be negative, and at a billion it would be positive. And for this one, well, it's always going to be positive. Now, something you have to be worried about is time can never be negative. So this time is negative 1 doesn't actually exist. So we're going to stop or start at 0. So this is all we're interested in, is from 0 on, because time can never be negative. So it goes from negative to positive, our velocity, and our acceleration is always positive. Okay, next question. Find the initial conditions. So that's just when you have time is equal to 0. So when time is equal to 0, we look at this one, your displacement is equal to 1. So when t equals 0, this is 0, and left is 1. So s of 0 is equal to 1. Your velocity when t equals 0, you have a negative velocity. So v of 0 is negative 3. And your acceleration is 0. A of 0 is equal to 0. So we plug that into that formula. Okay, we could do the same at 2 seconds. And now we're going to figure out, when does the position of the particle change directions? So when does it change direction? Well, that's when your velocity changes from positive to negative. So that would be at 1 second. So the change of position was at t equals 1. So if I was drawing a motion diagram for this particle, so it was going to go this way. It was negative velocity, and then it changed to positive velocity. And it started at time is 0, and it changed at time is equal to 1. Next one, what is the time interval, and is the particle speed increasing? So when is it increasing? Well, if we look up here, that's when the velocity and the acceleration are the same, both positive or negative, and that's when it's increasing. So when is, looking at this, when is it both positive or negative? Well, it's positive here for the velocity, And it's also positive for here. So anytime where time is greater than 1 or equal to 1, so when t is greater than or equal to 1, because they're both positive, and therefore the speed is increasing. What is the total distance traveled? Well, the total distance, so what you have to find is the distance from 0 to 1 second. Okay, so you plug in your distance. So going back to this form, this is your distance. At 0 seconds, you're at 1. So s of 0, you're at 1. And then at s at 1, so s at 1 is 1 minus 3 plus 1. So 1 minus 3 is negative 2 plus 1 is negative 1. So I went from distance at 1 at time is 0 to negative 1. So I've gone a distance of 2. Distance is 2. Then what happens when it goes from 1 to 2? So s of 2, that's 8. That's equal to 8 minus 6 plus 1, which is 2 plus 1, which is equal to 3. So it goes from negative 1 to 3. So negative 1 to 3 is 4. So this distance here is 4. And therefore your total distance, is equal to 2 plus 4, oh, sorry about that, which is equal to 6. Anyways, we'll talk more in depth about this in class. Hope you have a good day. Bye-bye.